So in the second part of this, I'm just going to keep working out problems from our final exam review. Here we're going to answer these questions relative to this graph of this function. So whenever we want to talk about a graph, we always want to think y is equal to f of x. That's the graph we're plotting. We're graphing that equation. All right, for this first one, we want to ask if we're plugging x equals 4, what's y? So we go to 4 on the x-axis, go up to our point on our graph, go over, and we get 2. If we plug in 0, well, the graph's actually right there at 0. It's at height 0, so f of 0 is 0. For this second one, again, f of x is representative of y, so we're really saying if y is equal 5, what are the corresponding solutions, or how many x's are associated to that? So we go to the height 5, and then we go left and right, and we see that our graph intersects that line 2 places, so we have 2 solutions of this equation. There's 2 values for x for which the function is equal to 5. All right, now for the second, for the part D here, there's only one solution because there's only one point on our graph at height y equals 0. We want to know where's the function increasing, where's the function decreasing. That just means where's the graph going uphill, where's the graph going downhill. So let me just clear this off. Our graph is going up from that point to that point on the graph. Now we want to know over what interval. That means over what open interval on the x-axis. So that turns out to be from -2 to 2. We don't say that we're increasing at the point 2. Okay, we just make sure it's an open interval. And likewise, our graph is going down on this portion of the graph, or our function is going down on this portion of the graph. That's over top of the open interval on the x-axis from 2 to 4. Okay, so that's our open interval for where our function is decreasing. What's the domain of the function? That's where we want to know what x values are we plugging in. The range is the corresponding y values. So we're going to look at our graph and look where does it show up over top of the x-axis. So the furthest most point to the left is here at x equals -2. Look for the furthest most point to the right on our graph. We see that that's happening at x equals 4. Those are solid dots on our graph, so it's from 2 to 4, including the endpoints 2 and 4. So we're going to have to use closed interval notation for our domain. It's -2 to 4. For the range, we want to know the corresponding set of y values. So we're going to look for the lowest point on the graph and the highest point. And we want to know what are the y values associated to those lowest and highest points, and is every value in between taken on. So we see the lowest value and the highest point, lowest point and highest point, and that's from -8 to 8. All right, so our range of our function here is -8 to 8. Okay, moving on, we're going to go on to this group of problems. Okay, for this group of problems, we're given a fixed function f with domain -1 to 5, range -2 to 6. And here's one example of one kind of function that illustrates that behavior. Now, in each of these parts below, we're going to be describing a different function. We're calling it g each time, which is a transformation of the function f. So we want to know what happens to the graph, describe that in words, and then how is that related to the domain and the range of the transformed function. So I'm going to do 2 of these examples. I'm going to do 15 and 16 and let you think about 13 and 14. For 15, the -3 on the inside tells us to move our graph right 3 units, or that transformation shifts the graph of f right 3 units, and then adding 11 on the outside moves it up 11 units. The right 3 tells us to take our domain -1, 5 and shift it right 3 units. We can accomplish that by just adding 3 to the left and the right endpoints of our interval. So we're going to add 3 to -1, add 3 to 5. Our new domain is from 2 to 8. Okay. Now for our range, only thing that's happening vertically for this transformation is that we're shifting the graph up 11 units. So we're going to take our range interval and move it up 11 units, and that gives us the new range, which we obtain by just adding 11 to -2 to get 9, adding 11 to 6 to get 17. And that's it. Those are our new domain and our new range for this new function g. All right, so for number 16, we only have outside um, effects here. So that's going to be vertical transformations. We're stretching it vertically by 3, and then afterwards we're moving it up 8. Notice the multiplication by 3 we do before the addition with 8. We always multiply before we add according to the order of operations agreement. Now, since these are only outside changes, we're not affecting what's going into the function, the domain is the same. It's negative 1 to 5. For the range, we're going to stretch it by a factor of 3, which means multiply by 3. And then we're going to add on 8. Okay, so again, we multiply the endpoints by 3, and that gives us negative 6 and 18. And then next, we're going to add 8 units on to the endpoints. Okay, so we're going to take that and we're going to shift it up 8. So we're going to add 8 to each number in that interval. So add 8 to negative 6, add 8 to 18, and that gives us the new range for this transformation is 226. Okay, and that's the answer for number 16. Domain stayed the same. The range is now 226. Okay, let's take a look at a couple more. So for 17, you want to find the formula for the composition. All right, the definition of this notation, f composed with g of x, is that you take the function g and you plug it into the function f. So it's f of g of x. So we put the formula for g, which is 2x plus 1, 2x minus 1, into the formula for f. All right, and we're going to do that by just putting open parentheses wherever we see an x. So we're going to say we got to square our input and then add on 3 times our input, which in this case is 2x minus 1. So we're going to put that in the gap here and here. And then just do algebra to simplify it. So we're going to square out this binomial. So we're going to say it's 2x minus 1 times itself, 2x minus 1. We have to distribute each term to each term. And then we're going to multiply the 3 through the parentheses to get 6x minus 3. Okay, now we're going to multiply this out. So we get 2x times everything in the second polynomial, the minus 1 times everything. So we get negative 4, or we get 4x squared minus 2x plus 1 plus 6x minus 3. And then simplify to give us 4x squared. We get negative 4x plus 6x, which is plus 2x, and then minus 2.